I thought I'd try to give a brief tutorial on assignment 24, section 5.3. Actually, this was not a very difficult section. I think your teacher actually gave you a break this time, but one of the first important things you need to learn how to do in the chapter is how to shift between or switch between logarithmic and exponential forms. And really it's not too hard to do. The main thing you need to remember, and this is sort of the definition of a log, just remember in your brain sort of the mantra and say this over like a few times in your head. The power to which the base must be raised to equal the argument. The power to which the base must be raised to equal the argument. And that is basically what a log is. So, for example, say they give you something like the log, and we'll call the base b, log base b of a, which is the argument, equals some number. Another way of writing this, and it means the same thing, it's just an alternative way of writing the expression, is b to the power of n equals a. So it's the power to which the base must be raised. Here's the base, the power to which the base must be raised, and n is the power to which the base must be raised to equal the argument. So just go over that and manipulate that a few times in your mind, and I think it'll really help you out. They give you some problems. Actually, the first 4 problems he gave you in the set kind of is switching back and forth between the exponential and the logarithmic form. So let's try and go over that. The first problem they gave you was 9 equals 3 squared. So here we can write it another way. We consider this part to be the base. This is the power to which it has to be raised. And this is the n, or actually this is the a. This is the argument rather. So that's the argument of the algorithm. That's the power or the number that the base has to be raised to equal n. So another way of writing it would be log base 3 of 9 equals 2. Again, 3 squared equals 9, or log base 3 of 9 equals 2. They're sort of they are actually inverses of one another. So anyway, let's go to another one. Let's go ahead and pick up 8. That one they give you 3 to the x power equals 4.6. And again, it's the power to which the base must be raised. So here's the base here. Here's the power, or in this case it's a variable. And here we have the argument. So if you want to write it another way, it would be log base 3 of 4.6 equals x. And you could actually calculate the numerical value for log base 3 of 4.6 and get a number value for x, but in this case they just wanted you to switch back and forth between the two forms. So that's sort of essentially what we've been doing. Let me move on to the next one. Okay, here you're going to be going in reverse. So they give you, for 13, they give you log base 2 of 8 equals 3, and they want you to convert this into exponential form. Again, just keep remembering it's the power to which the base must be raised to equal the argument. So here's the base, here's the argument, and here's the power that it has to be raised to. Or we called it n in our case. So 2 to the third power equals 8. And in fact it does. 2 times 2 is 4 times 2 is 8. So that one works out. It's just alternative ways of writing the same thing. And then again in 20 they sort of give you an example with variables instead of numbers. So they give you log base 3 of n equals 21. In this case, it's a little bit tricky because they switched the. I'm using n for my variable for the number, but in this case, they're using n as the variable for the argument. So try not to get too confused. Anyway, just looking at it, it's easy to see that this is the base, this is the argument, and this is the power to which it has to be raised. So you go 3 to the 21st power equals n. Or is that 20? Oh, I'm sorry, it's not 21, it's 2.1. Okay, 3 to the 2.1 power. Okay, so log base 3 of n equals 21. Another way of saying the same thing is 3 to the 2.1 power equals n. So I'm going to switch to another page and keep going through these problems because I think it's kind of helpful and you want to be able to get it down. But anyway, just remember this part up here as much as possible. The power to which the base must be raised to equal the argument, and that'll help you switch back and forth between these kinds of problems.